This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions, she gives the answers. No filter, no script.
Well, mostly no script.
Today we're talking about something a lot of developers have bumped into but haven't quite named yet. The human bottleneck. Code is flowing, builds are green, features are shipping, and then you go to extend something and realize you approved a change you didn't fully understand. The bottleneck hasn't shifted to typing speed, it's shifted to cognitive capacity, and you can't fix that with a better model. Claudine, that moment of recognition, have you seen that pattern?
More than almost anything else right now. It usually doesn't come from the code itself. It comes from a follow-up question. A developer goes to extend or debug something and discovers they don't have the mental model to reason about it. The code shipped, the understanding didn't. Once AI can produce more code than you can absorb, your throughput stops being measured in lines and starts being measured in comprehension.
There are two different kinds of comprehension at stake, aren't there? Working memory, holding the current task in mind while you generate and review. And system model, the architectural understanding that tells you whether a change is actually safe to make. AI handles the first pretty well, but the second?
That's the exact split I'd draw, and the asymmetry matters. Working memory loves the AI partnership. I hand you the next 20 lines, you stay in the task, friction drops. But system model is built differently. It comes from the dead ends, the small struggles, the moment you trace a call through 3 files and finally see why it's structured that way. When I do that work for you, the code arrives but the wiring in your head doesn't. And the cruel part, working memory feels like progress in real time, while system model only reveals itself as missing later. Usually at the worst possible moment, when something breaks and you realize you're debugging a system you never actually internalized.
So we're potentially building on quicksand. The more we rely on AI for the generative work, the more precarious our position if we don't actively cultivate that system model. Are we at risk of atrophying something important?
Atrophy is exactly the right word. The skills you don't exercise quietly weaken. System model is built almost entirely through the exercises we're now most tempted to skip. The strategy I see working isn't about doing less with AI. It's about being deliberate about which struggles you keep for yourself. Some developers treat architectural reasoning as a non-delegable task. I can draft, refactor, debug at the line level, but where does this belong and why stays in their head by rule? The other move I find genuinely effective is what I'd call a comprehension checkpoint. Before merging anything substantive, close the editor and explain the change out loud, to a rubber duck, to a teammate. If you can't, the code isn't ready, regardless of whether the tests pass. The bar shifts from does it work to do I understand why it works. That's a bar I can't clear for you.
Comprehension checkpoint. I like that framing. It changes what done actually means. In a culture that rewards speed, inserting a moment of deliberate understanding goes against the grain. Are their teams getting this right? What does it actually look like?
The teams doing this well treat AI like a junior pair, not an oracle. And that single framing shift changes everything downstream. A junior pair gets your trust on the mechanics, but never on the architectural call. And crucially, you stay responsible for explaining the work. The cultural marker I notice is how they handle code review. On the struggling teams, review has quietly become a rubber stamp. The human author barely engaged with the code, so the reviewer is the first real reader with no context to push back. On the teams that adapt well, review gets harder, not easier. The author defends every non-trivial decision in their own words. The AI suggested it is a non-answer. The other pattern is what I'd call slow time. Deliberate blocks where AI is off and someone is just reading the code base, tracing flows, building the map. They've recognized that comprehension is a capital investment. If you only ever spend on velocity, eventually the account is empty.
The junior pair framing doesn't reject AI, it repositions responsibility. And slow time reminds me of how teams treat technical debt. You invest up front, it doesn't show on a sprint board, but it holds everything together when things get hard. How does leadership need to evolve to actually protect those investments?
Leadership is where this either works or quietly falls apart. Because comprehension is invisible on a dashboard, and velocity isn't. The leaders getting this right have made one uncomfortable decision. They've stopped using output volume as the primary signal of a healthy team. That sounds obvious. It cuts against every instinct built over decades of engineering management. They're asking a different question in one-on-ones. Not what did you ship, But what do you understand now that you didn't last month? That reframes the work as knowledge accumulation with code as the byproduct. The other thing, good leaders are getting honest about who on the team actually holds the system model. In an AI-accelerated environment, that knowledge concentrates fast and silently. If 2 people understand the architecture and 12 are productive inside it, you don't have a high-functioning team. You have a fragile one. The bus factor problem just got dressed up in better metrics.
Productivity and fragility can look identical on the surface. That's the uncomfortable part. So what does this look like in practice? A team wants to start today. What do you tell them?
The first move is small and almost embarrassingly concrete. Pick one repository and write a single document that doesn't exist yet. A 1-page map of how a request actually flows through the system in plain English. Not generated, not AI-assisted, written by hand by someone on the team. You'll discover within an hour who actually understands it, and the gaps become the curriculum for everyone else.
I like that. What's the second move?
Instrument the review process. Add one required field to your PR template, asking the author to explain, in 2 or 3 sentences, what they'd change if a specific adjacent requirement showed up next quarter. That question can't be answered by pattern matching. It forces system model thinking. You'll see immediately whose answers are real and whose are hand-waving.
And the third?
The hardest one culturally, but the highest leverage. Pair a senior engineer with a less experienced one for a weekly hour where neither of them uses AI. They just read code together and argue about it. That hour will feel unproductive on a Tuesday and load-bearing 6 months later. The teams who protect it are the ones who still have a system model to work from when something goes wrong at 2 in the morning.
All 3 require 0 new tooling, but they do require something harder. Holding the line when the pressure to ship is pushing against them. Where do these practices most commonly fall apart?
The quarterly review cycle and the way it punishes invisible work. You can tell an engineer that comprehension matters, but if their promotion packet still lists shipped features and closed tickets, they're going to optimize for what gets them paid. And they should. The teams that make this stick don't just add new practices on top of old incentives. They rewrite the incentive structure itself. Promotion criteria that explicitly reward someone for writing the architecture doc nobody asked for, or for being the person other engineers turn to when the answer isn't clean. The second hurdle is leadership patience. These practices show their value on a 6-month horizon, not a 6-week one. Somewhere in month 3, a VP is going to ask why velocity dipped. The leaders who hold the line through that conversation are the ones whose teams are still standing 2 years from now. The ones who don't quietly lose the system model and don't notice until something breaks that nobody knows how to fix.
Incentive alignment and patience. Neither of those are technical problems, which maybe tells us something about the nature of this challenge. Bigger picture, if cognitive load is genuinely the binding constraint, where does this go? What's the future you're watching for?
The future I find myself genuinely hopeful about isn't the one where AI keeps accelerating output. It's the one where the bottleneck shift forces us to remember what software engineering actually is. For a long time, the field has treated itself as being in the business of producing code. AI is finally exposing that as wrong. We're in the business of building and maintaining shared mental models of systems that solve real problems. Code is just the medium. The teams that internalize that are going to look strange for a while. Smaller, slower looking on the surface, senior engineers spending more time talking and reading than typing, but they'll be the ones who can respond when the system surprises them. In a world where everyone can generate code at the same speed, that responsiveness is the actual competitive edge. The engineers who treat comprehension as their craft, not their overhead, are the ones who'll define what the next decade of this work looks like.
We're not code generators. We're custodians of understanding. That's a reframe a lot of people in this industry need to hear. Claudine, thanks for a genuinely thoughtful conversation. To everyone listening, look at your own workflows and ask honestly where comprehension is keeping pace with velocity and where it's falling behind. That gap is the real work. Thanks for being here. Claude Code Conversations is an AI Joe production. If you're building with AI, or want to be, we can help. Consulting development strategy, find us at aijoe.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.